what we should merge. And the suggestion was to merge to master. Would it have mattered if we had merged from master out to our collision branch? So if we had gone, you know, from master out to the branch. So let's go back and take a look at that scenario. So we'll move master, which we're on, back to where it was before. And then we'll check out to our collision branch. Okay, and so instead of switching to master first, if we just stayed on collision branch and did a git merge master. Would we still get a collision?
Yep.
Yeah. Let's see what our status says. Looks a little different, doesn't it? If you recall, the last time we did a git status going the other way, the only change we had was git ignore, right? But since we're coming from master out to our git collision, master has a lot more changes, and those actually did get merged, right? They're ready to go. But our git ignore, of course, is still an issue. So yeah, here we are back with the change. The order is different, right? Now head is our collision branch and not master. So we would still accept, you know, whatever we're going to do. I don't know what compared change it does. Okay, interesting. I haven't used VS Code much. So accept, save. And so on and so forth. Is there a case, do you think of where you'd want to choose one direction versus the other? Like where you'd want to merge out to your branch instead of into master?
I'm guessing if you merge into your branch, you can deal with collisions. Then you can switch to master and then merge again so that you have a cleaner history, or not. Or maybe you can cherry pick into your collision branch, resolve the conflict then.
Yeah, so this kind of gets back to workflows, right? So if it kind of depends how your team is using the different branches. So if, you know, if master is kind of your development mainline, you're going to have a lot of incoming changes to master. And so if you can go ahead and merge onto master, sure, and that's how you know how changes come on there. But if you've done that, and maybe it's been a while since you've last visited master, there's a decent probability that your changes are not going to be acquainted with what's going on master, and which means a decent probability it's going to be a mess for you. And then if you go ahead and commit it, then it'll be a mess for everybody else. So the more sane way to do it in that scenario would be to first merge out from master. You know, get yourself acquainted with what everybody else has done on your team. You know, run the tests, familiarize, make sure it all works. And that's, you know, that takes some time, but it takes a relatively small amount of time compared to all the time that you're pulling out from master onto your branch when you merge. So ideally, you can get it sorted, get it working, and then you commit back to master, and then there's a much smaller change set going on to master with that merge than if you had just wholesale just plopped your stuff on top of a bunch of new developments on master. So so yeah, generally you want to merge out first from the main line of development, and then merge back in once you've got your got everything sort of sorted out as it relates to your changes. Okay, so got about 3-4 more things to cover here. Touch briefly on stash, get stash. So there's not a whole lot to it really. Just a few kind of options to it. Basically, if you've got a change you're making, so used to using BI. So if you are working on a file, you have the file and you've got changes. But then suddenly you get called away. You're on your branch, but now you've got a production issue. Okay, now you need to go fix that on that branch and then come back. So the easy way to just put everything aside, even if you've got things that are going to be committed. So maybe I'm going to commit this guy and then, or commit, not commit it, but stage it. And I've got another change here. Right, and I save that. So now I've got something staged and something modified. I can get stashed the whole thing. And now, now there's nothing there. And then I can kind of see what's on my stash, which is just a stack. There's one thing on my stack. So, I'm on collision branch. Maybe I need to go to master. So now I can go to master and do whatever work here. Add it, commit it, get it all delivered. And now then I can go back to my stash by doing a pop. Important to keep in mind that your stash is just a snapshot of your, what's modified and staged. It doesn't know what branch it was on. There's no branch attribute to a stash. So I could pop it onto here, but remember I was on a different branch, so probably that's not where we wanted to be, right? So okay, now it's gone from my stash. But if I say, oh shoot, I was on my, I was on my other branch. Let me go back there. Okay, that it lets me do that because there's no collisions. If there were collisions, it would just leave the stash on my stack, and I could go to the branch and then get stash pop. So you want to play with it a little bit. Notice it's not exactly the same as I left it. It was actually staged before. So, it has a few little nuances to it, but it generally works really well and does about what you expect it to do. Just to put something aside and come back to it later. Get stash and then get stash pop. So, I won't ask for questions about that because that's about all I know. So you can always do, get help anything, get help stash. and get way more than you ever wanted to know about everything about Git. And yeah, by the way, you know, Q quits out of all that. Spacebar goes through, arrows go through, all that too. So good enough. So let's look at Git rebase a little bit, and a very little bit. We're just going to look at one specific scenario where Git rebase comes in handy, but it again, it's around this theme of communicating effectively. So, okay, where the heck am I? Let's go to master. Let's see where I'm at on master. Okay. Good enough. All right, so is that where I wanted to be? Yeah, it is. Okay, so I'm on master. Suppose I am, you know, stumbling along and I am modifying test.sh. And, you know, make some changes. And test.sh just does a very simple thing. We'll use it in a little bit, but it's just a simple shell script. And you can run it with bash. Right. Well, I haven't saved it, so. So right now it does something fairly mysterious. It doesn't actually print anything out to the screen. It just sets an exit code, Linux exit code, based on what it finds in the file text.txt. So let's just suppose I want to make it actually print out to the screen. All right, and it's looking for the string Wallace, but say I want to make it look for the string, like print out one line that has the word 20th in it, right? Save that. Okay, there's that. So I'm going to add it, commit it. Lines with 20th, all right? Bear with me here. Okay, and then I should just get rid of those, these other guys. Oh, I haven't added it yet, have I? Okay, there we go. Now I can commit it. Okay. So then I realized, oh, well, I need to test it. Oh, it doesn't work. Okay, that's because it's actually not printing anything to the screen. So let me get rid of this stuff that clobbers is output to the screen, and then I'll add that. Whoops. All right. Oh, wait, I forgot to test it again. Let me try that. Ah, shoot, there's more than one line. So, okay, here's late. So we've got, here's late 20th. Here's late 19th century. Here's early 20th. Okay, well, that's the problem. I didn't make it say early 20th just to get one line. So I go do that, right? So clearly my test methodology needs some work, right? So okay, oops, I forgot to test it again. Let's see if it works. Ah, it's still getting 2 lines. Okay, well, it's because I didn't put, I had to put this in single quotes. That's what's going on here. Let's try that. Okay, that's the change I wanted, I think. So you kind of see where I'm going. Making changes that are really not something I want other people to see. my struggles. Right, so I've got all these changes. Okay, there's one line. This actually is all one line. So it finally worked. Let's look at my history. And you know, there's all my changes, which I really don't want to push up in that form. Wouldn't you agree? So get rebase to the rescue. So what we can do is basically squash and modify and get the same ultimate set of changes, but package them up as different commits, and possibly even a different order of commits if we want to. In this case, I'll just do a very simple sort of squashing down to one commit, but here's how that goes. So assuming that you've got your VS Code set up to be your editor, this comes in handy in this case too. The drill is you look and see where something is that you want to keep, which is probably back around here, and give that as an argument to get rebase. So here's how that looks: get rebase dash I. I can just say origin master. Okay, and it is a handy message as to what's going on. So here I am in my editor. First thing to note is that anything in comments is not going to actually get saved or dealt with. It's just this stuff up at the top. So these are all the commits since the one that I chose. So notice origin master itself is not in here, but all the ones after that are. So what I would like to happen is for this all to be just one nice commit, with the set of changes that eventually resulted. And these comments down here kind of tell us what our options are. The one we're going to use is squash. Use commit, but meld it into the previous commit. So like, for instance, this guy, if I take the word pick here and change it to squash, or just S, I can just use S as well, then this change will get combined with this change, and it'll end up being one commit instead of two. And I can keep doing that. I can say, well, do the same with this guy as well. And then both those commits will get mashed into the commit before those, and those three commits will turn into one commit. And then pick will just kind of, we'll keep at least one. You can't squash everything to no commits. So if I save that, and it says I need to close the file too, not just save it, right? So if I close it, then it goes to the next step. So now it's done that squashing. Now it says, okay, what kind of comments do you want to keep in here? So again, anything that's not commented out with the hash mark will be used. So here's my opportunity to say, what I really wanted to say, right? This was my ultimate goal, and get rid of all the cruft. And blank lines too don't get kept as well. So I save that. Get out of here. Okay, now I'm all done. Let's see what happened. So here's where we started. Here's our commit right here, and here's our comment that we ultimately came up with. And that's something I can push up and that will make sense and not, you know, create a lot of clutter for whoever's trying to read through what actually happened. And I can look at what the difference is. And sure enough, it's exactly, you know, what the eventual result was from all those commits. So that's pretty cool. I'm gonna back away again for a few minutes and let you guys try that, because I think that again is another practice that really comes in handy and is worth getting into your toolbox. So this is this section right here, and then we'll go into a fun little exercise with get bisect. But this is it here. I'll be back in about 5 minutes. Okay, I'll just get rebase going.
That feels like more intuitive, I guess, to me.
I'm sorry?
It feels slightly more intuitive to me.
Okay. Yeah, I've had you know, good success with squashing and mixed success with you can actually change the order of the commits. You know, just put lines in whatever order you want, so it keeps the commits but plays them in the order that it sees them in the file. And depending on what the changes are, sometimes that works great, and sometimes it completely fails. And that's when git reset comes in handy. But definitely a useful tool. Okay, so I'm going to finish off. I'm probably going to finish a little early here, but this is kind of a fun exercise for a scenario where you say you're on a large project and a lot of changes are coming in, and maybe you have a test suite that runs automatically. There's a lot of teams at DRW do this. But because of the the nature of the tests and the people learning the system and other factors, that a change that causes a problem may not get caught right away. And so our test suite will email people with you know uh, the breaks that happen if they do actually break the test suite. But we're kind of thinking about a case where that hasn't happened, where the test suite thinks everything is fine, and then a while later we find out that it's not, and maybe then write a test that catches it. But the problem is where did it start? And so imagine 100 commits, and you've got to find the commit that caused the problem. So one way to do that is just to keep checking out half of the commits back. Go back 50 commits and see if it works there. Okay, if yes, then bisect the next 50 to 25 and do that. So that's something that Git can do for us, actually, with Git bisect. So let's imagine a scenario where we have what we consider a bug. Got this file here, and it's basically a wiki article that I pulled out on cargo cults. And at some point, the word Wallace came in, and we're going to consider, for our purposes, that the word Wallace is our bug. And so when the word Wallace starts appearing, that corresponds to our bug becoming, part of our life. So, if we grep for Wallace, grep is, if you recall, get regular expression print. There it is, right? There's the paragraph with Wallace in it. That's a bug. So our problem is to find out when that got in there. What commit produced that paragraph. So there's quite a few commits. So Git bisect lets us formally, or sort of in a disciplined way, narrow down that commit to exactly which one it is. So the way you go about that is first you find out when it was good. So it can be anywhere before the bad commit. So let's just pick line 1 here, 976.724E. So here's how we tell Git what to do. We say git bisect start, and then we give the bad commit first, which is where we're at right now, and then the good commit, which we'll say is this 97624E. Okay. And then it tells us a little bit. It says we have 18 revisions left, about 4 steps. And if we peek a little bit into the repo, we can see that there's some state that it's collecting for its purposes. We can also look on the graph and see a little bit about it as well. See, now we've got to get a refs bisect bad here. And if we go down here where we started, we've now got a refs bisect good. So you can see it keeping track for us. But we don't really need to know exactly about how that happens. All we need to do now is run our test and see if it's good or bad. So we're somewhere else right now. We're actually right here in the middle, right? This is the bisect that it did for us. But it moved head down here for us to work with. So let's run our test, grep, Wallace. Okay. So is that good or bad?
Good.
That's good. Yeah, Wallace is not there. So we just tell Git that. Git says, okay, well, that means I'm going to move your head over here now. All right, so now we run our test again. Oh, now it's here. That's bad. Okay, moved our head again. Oh, now it's good. And it keeps saying, here's how much you got left. All right, we're getting close. Run our test again. Oh, that's bad. Okay, we're almost there. Run our test. And it's not there, so that is good. So it says, here's your bad commit. So are we actually on that bad commit? No, we're not. So 3331 is right here, right? So it left us at the last good one. Right, so we can do whatever we feel like is right there, but at least we know which commit it was that caused that bug. Right, does that make sense? Now we can do a little better. So now that we know everything we need to know, maybe we do a git branch the bad commit, right, off of 3331, and then we can go off and branch and fix it, test it, et cetera, et cetera. But once we've done that, we can just do a reset, and then that clears everything out, puts us back on the tip of master. So here we are back on master where we were before. Of course, now we've made ourselves a branch back where we care about as a reference point. So there's a better way to do it, because you can lose track of, okay, did I run bad or good? Have I run the test yet? What is my test even? What's going on? So what you can do is come up with your own script. And that's where we come back to this test sh. I'm actually going to get reset back to origin master because I've screwed up my test sh. So let me go back there first. Okay, that's what it should say. So if we run this, okay, did anything happen? Actually, yes. What Git keys off of when it's running git bisect and you give it a script is the exit code of that script. And if you're not used to Linux, it's a little backward from what you might think it should be. Because 0 seems like false and 1 seems like true in most worlds, but in Linux, it's the opposite. 0 is good and non-zero is bad. So what this is telling us is that it actually did find Wallace, and that's bad. So you have to keep that in mind in Linux land. But our script is working. We don't care about the output really. That's why it goes to dev null, which is basically throwing the output away because we don't need it. We just need to know if it found it or not, and that's what grep does. If it finds it, then that's what we care about. And then we exit 1 if it does, and exit 0 if it doesn't. So how do we get Git to run that? We kind of the same way. We start it like we did before. And I think was it 977 something? Boom, 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 boom. 976, that's good enough. Okay. But now we can tell it to run the script instead of us having to handle it ourselves. So here we go. Done. There's our bad commit. So yeah, a little faster than trying to do it ourselves. So let me back away here again and let you guys try that. Find yourself some commit back in the distant past. Oh, also I've got to do a git bisect reset. Recall that what we're using was the presence of this word Wallace. You can use something else if you want. So yeah, I recommend giving that a shot with your kind of the manual approach, and then seeing if you can get test.sh to work. Pretty much everything you need here, I believe, is present. But you always learn things when you try it yourself. So let me back away and give you about 10 minutes to try that, and be back. It's about time for a break again at 2, isn't it? So maybe about 5 after 11.